We're looking at number 7 on page 386. They're asking you to graph f of x, I should say, equals x squared minus 5. That's another way of saying y equals x squared minus 5. We're just graphing a quadratic function, a parabola, same thing. So the way they want us to do this is to find our axis of symmetry by using negative b over 2a. The axis of symmetry is always going to be a vertical line, so it's going to have an equation of x equals something, and that x is going to equal whatever negative b over 2a equals. So in this equation, a equals 1, b equals 0 because there's no x term, and c equals negative 5. So we go here and plug in negative b and 2a. It looks like b is 0 here, so x equals negative 0 over 2 times 1. Doesn't matter, if 0 is on top, x is going to have to equal 0. So the axis of symmetry for this graph, if that's our y and that's our x, the axis of symmetry is going to go right through x equals 0, which is right, it's the same exact thing as the y-axis. So our axis of symmetry is x equals 0. So this parabola is going to go right through here, that's going to cut it in half. Now to find out actually where on that thing it starts, we plug this 0 in back for x in the original problem. So now we have 0 squared minus 5. We get negative 5 for that. That's the y-coordinate of our vertex. So now we have 0, negative 5 as our vertex. So the x-coordinate of our vertex is going to be negative b over 2a. The y-coordinate of our vertex is going to be whatever we get for y when we plug 0 back in for x in the original equation. In this case, we got negative 5. So it looks like 0, negative 5 is going to be the vertex of this parabola. We also know, and this may be something new, we haven't actually gone over this, but if a is positive, in this case it's positive 1, the vertex is, or I'm sorry, the parabola is going to curve upward. It's going to be going up this way, which means it's going to have a minimum point somewhere. The minimum point is going to be at the vertex. It never goes below that. The minimum point is just the y-coordinate of the vertex. So if they ask you for the minimum of this graph, you can just say y equals negative 5. So if they ask you for the axis of symmetry, you're going to say, for this one, it's x equals 0. It's always going to be x equals something. In this case, it's x equals 0 is the axis of symmetry. And the minimum point is going to be y equals negative 5. Means anywhere, the minimum point is actually 0 comma negative 5, but you can just say the minimum of the function is y equals negative 5. Either work. So you can give the vertex here. If they ask for a minimum, you can say 0, negative 5, or you can just say y equals negative 5. That's number 7 on page 386. Let's do number 15. So we have h of x equals negative x squared minus 8x minus 15. This is number 15 on page 386. So for number 15 on page 386, we have x squared minus 8x minus 15. So they want us to graph that. So we again, in order to start our graph, we need negative b. We need negative b over 2a. So let's get our a, b, and c. So a equals negative 1, b equals negative 8, c equals negative 15. So negative b is going to be negative 8. So x is going to equal this. So negative 8 over 2 times negative 1. So x equals 8 over negative 2, which is negative 4. So x equals negative 4. So what that means is when we graph this parabola, there's our y and there's our x, the x coordinate of this vertex and also the axis of symmetry is going to be at negative 4. So the equation of this line is x equals negative 4. So we know that's going to be the center point of our parabola. We don't know whether it's going to slope up or down yet, and we don't know where the vertex actually is, but we know this is the middle part of the parabola. This is what cuts it in half. I also look up here, I see a is negative 1. I have a negative coefficient there in front of x squared. That means I know this thing's going to open downward. Any parabola that has a negative coefficient there in front of x squared is going to open downward. We need to figure out now where the y-coordinate of the vertex is. So we just plug in this negative 4 in for x in the original problem. So now I have negative 4 squared minus 8 times negative 4 minus 15. This is going to be the y-coordinate of our vertex. We've already found the x-coordinate of it. It's negative 4. So I do negative 16. Negative 8 times negative 4 is plus 32 minus 15. Negative 16 plus 32 is 16 minus 15. Y equals this. So y equals 1. So our vertex is negative 4, 1. We got negative 4 up here, and then we plugged it back in to find y. So our vertex is negative 4, 1. This is the vertex of our quadratic function here, of our parabola. We know since it's a negative here, we know it's going to have to open down, which means this point is a maximum. It means the parabola is never going to get above that point. So we can say that y equals 1, which is this line right here, is the maximum. You can also say negative 4, 1 is the maximum point. So it means the parabola never goes beyond the line y equals 1, and it never goes, its maximum point is at negative 4, 1. So that if they ask you, if that's what they were asking on that problem, which I think it is, let me check. Yeah, we found the coordinates of the vertex, negative 4, 1. We found the equation of the axis of symmetry, which is x equals negative 4. And then we found the greatest value of the function is right here at y equals 1, or you can say negative 4, 1. Those are the same thing. Okay, let's move on to number, we were supposed to do up to 25 every other odd, I think. So I'm going to do number 25 here. So 25 on page 387. 25 on page 387 is y equals x squared minus 4x. So if we want to graph this thing, we're going to have to, well, they tell us to do it a different way here. They want us to use the vertex and 4 other points, so I'll show you how to do that. It's a good way to get a perfect graph. So we always have to find our axis of symmetry first. So I'm going to get A, B, and C. A is 1, B is negative 4, C is 0. So I'm going to get x equals negative b over 2a. So I'm going to get x equals negative 4 over 2 times 1. So negative 4 is 4 over 2. So x equals 2. So I'll rewrite this down here just so I have some room. So I'm going to say x equals 2. That's our axis of symmetry. So again, when we graph, if x equals 2, that means this is the axis of symmetry. Write down where x equals 2. It's going to be a vertical line through that point. So now we have to find our y-coordinate of our vertex. What we do there is plug 2 back into our original equation. So we get y equals 2 squared minus 4 times 2. So y equals 4 minus 8. Y equals negative 4. That's our vertex there. So this thing looks like it's going to be at 2, negative 4. We know it's going to open up because a is positive. So we could kind of sketch a graph here, but we want to actually find points that work. So what we're going to do is we're going to make 2 points above and 2 points below the vertex. They're all going to be above the vertex, but 2 x values above and below this value on the vertex. So I'm going to say 3 and 4. So I went up 1 and another 1. That means I'm going to go down 1. So this is going to be a positive 1. And then I'm going to go down another. That's going to be 0. For all these now, I'm going to plug back in to find y. So if I plug in 0 for x, I'm going to get 0 minus 0. So y is going to be 0 there. If I plug 1 in, I'm going to get 1 minus 4. That's negative 3. If I plug 3 in, I'm going to get 3 squared is 9. Minus 12, so that's negative 3. Then I plug in 4 here. 4 squared is 16 minus 4 times 4, that's negative 16. So those cancel out and I get 0. So now I have 5 points, and because this is the same distance away as this, and this is the same distance away as this, it's just 1 and 1, 1 and 1, up and down. If we graph these 5 points, we're going to have a nice symmetric parabola. So we already have 2, -4. Now we're going to have 3, -3, and 1, -3, which would be here. Then I'll graph 0, 0, which is there, and I'm also going to graph 4, 0, which is about here. I should have done this on graph paper, but I didn't. But this is going to be what our parabola looks like once we graph 5 points. Which, when we really want to graph a parabola, we are going to have to use 5 points. First we find the vertex, then we go 1 up and 1 down, and then we go 2 up and 2 down. And then graph all 5 of those. We should be good to go. So that's the graph of the parabola. The axis of symmetry is x equals 2, just like there. And the vertex is 2, -4. I'll call this the AOS, axis of symmetry, is x equals 2. The axis of symmetry is always going to be x equals something, because the axis of symmetry is always a vertical line, and a vertical line always has the equation x equals something. There's no y component in it. Hope that helps.